Yesterday we went over the law of sines, and now we have to go over a special case of the law of sines called the ambiguous case. We made a list of all the congruence acronyms that went along with the law of sines. So that was like angle, angle, side, or side, angle, angle. There's also angle, side, angle. So you would have like a triangle with two angles and a side. You would be able to use law of sines to figure out all the other sides. And then we also had ASS. In geometry we talked about ASS, and it wasn't actually one that would work, or it would work under special conditions. It works for a law of sine, but you just have to be careful about how you use it. So here's what we do. Let's say, for example, that we have an angle A, and that angle is 20 degrees. Also, we have side A equals 10 and side B equals 3. Alright, so I can draw this. Actually, there are two different triangles. Let's say that this is 10 here, and this represents my angle of 20 degrees. Now, if you imagine that you had kind of a trap door here that could swing back and forth like this, you could have a triangle where the side of length 3 meets up with this dotted line right there. On the flip side, you could also have a triangle that has a side length 10 and an angle of 20, but that trapdoor, instead of going over here and meeting there like the other one, you could swing it out and it would be meeting back here. So these are two examples, two different triangles, two different sizes, but they follow ASS. So what ASS guarantees is that you can actually have two different triangles. And so the answer is ambiguous. There are actually two possibilities. So when you do this, what you will have to be finding this angle in the corner. And when you use law of sines, it's going to give you this one over here. The reason is that when you sine inverse, you're going to get an angle that's less than 90 degrees. It's the right side of the unit circle. It goes from 90 degrees down to negative 90. So when we sine inverse, we're going to be getting a small angle. This angle over here is going to be over 180, so that's not what our calculator will give us, but we'll explain how to get that in a moment. So law of sine here, we would do sine of 20 all over 3 equals the sine of theta all over 10. And we're going to have to do a little work here because we need to figure out theta. So I'm going to multiply 10 on both sides. And at the same time, I'm going to sine inverse both sides. So I have one expression that I can use to get that angle. Alright, so what I'm actually getting when I plug this in the calculator is theta is 65.8 degrees. Okay, so how in the world are we going to find it over here? Well, the cool thing about this is in the left-sided triangle. This right here is the side that is also 3, right? But if we swing it over, then we have the larger triangle on this side. This imaginary triangle here is actually an isosceles triangle, and if you remember anything about those guys, if these sides are the same, then these angles have to be the same. So what that means is this red angle here, which is this guy over here, is going to be supplementary to the angle we found here, because that angle plus the red angle should equal 180. So if you figured out theta and you actually want the obtuse version, you just do 180 minus 65.8, and that's going to get you the other version. And so I get 114.2 degrees. Okay, so on a test or a quiz, you would be expected to know that, hey, there are two triangles here, and if it's a solve, I have found the other angle, but in each case we're going to have different other angles and different sides. For instance, the green angle right here is going to be different from the green angle right here because the one on the right is going to be larger. And then you have to use law of sine again to figure out this remaining side here and here. So it's when you have this ASS thing and you have this swinging door, you will actually have to be solving two sets of triangles.